Intro to Elm. Let's do this. Sweet. So, hi, thank you so much for the nice introduction. And is the mic just not working?
Ooh. There it is. There's a sweet spot.
There is a sweet spot to it. All right, I gotta just not move. All right. Sweet. Yeah, it's extremely uncomfortable. It's awful. Today I'm going to be talking about Elm. First off, quick show of hands. How many people have used Elm in this audience? Yes. All right, perfect. I can say anything I want right now. You guys cannot call me out on it. This is ideal. Okay, so I hadn't heard about Elm before this internship, but we have this dude named Ashish at ExtraHop who is like an Elm evangelical. So he put me on to Elm. That was like literally 2 days into the internship. But what Elm basically is a functional programming language that's designed for front-end web development. It's really fast, it's really simple to use, and it's really cool. So let me hit the present. Yeah, that is a good idea. So a couple of reasons why you should actually use Elm. The first thing is it has this really cool elevator pitch. It's this idea that there are no runtime errors in practice. And the way it accomplishes that is because it's functional. It has a really good compiler. There's a lot of like pure functions, so it's super predictable. And then it also has an awesome typing system, which is why I'm bringing it up at this TypeScript conference. The other reason Elm is cool is because Dan Abramov totally ripped it off to create Redux. Redux is like the exact same as Elm. So you're going to see later when we talk about the architecture, it really closely resembles Redux. The other thing is that it's really fast, similarly to how the compiler knows a lot about what you're doing, so there's no runtime exceptions. The other thing is that it's really optimized because of that. So Elm actually outperforms Angular and React, which is kind of wild, and it's really cool. But I think the biggest thing is that even if you're not going to use it for any practical reasons, you're not going to use it at work, I still think it's worth learning just because it's a really good introduction to functional programming if you've never touched that. And then also you can draw a lot of inspiration from it. We have a library, I forget exactly what it's called, but it draws from Elm at ExtraHop. Remote data, yes. Yeah, we have like an entire section of our code that's like completely just like lifted from Elm. So you can get a lot of inspiration from it, and I also think like working with functional programming gives you a lot of good discipline when you move back into JavaScript. So now I'm going to open up what our end goal should be. I really hope that this thing works. Cool. Set turns. Great. Don't read this ever. Sweet. So what I have is the most boring proof of concept thing that you could possibly do. It's a counter with a decrement and an increment button on it. I'm less creative than Tyler with these things. So this is basically what we're going to try and strive for, and we're going to build this in Elm. But because this is a TypeScript conference, what I'm going to do is I'm going to build Elm in TypeScript, actually. So it's going to be a weird way of doing this where we get familiar syntax, and I'm going to contrast it to the weird syntax of Elm, and we're going to see how this all works. So the first thing that we want to think about is actually how the Elm architecture fits together. So what I'm going to do is I'm going to pull this guy up and side. What I wanted to do is bring this little counter thing up side by side just so we can compare the Elm architecture here. So the Elm architecture consists of like three things. The first thing is a model, there's a view, and an update. So what the model is it's basically just your state for the entire application. So in this case here, we have a counter, and really the only thing that's changing is this actual number here. So maybe your state would just be a single number that stores the actual count on your page, right? So another way you can think about it is that the model is really analogous to the Redux store, and you can just draw a bunch of stuff from that actual model there. So the next thing we want to think about is something called the view. And what the view does is it's a function that takes in our model, and deterministically it just outputs the HTML for the entire page, right? So if I created a view function and I passed in 1 as my argument, it should output the HTML for this entire page over here. So it's just a deterministic way to actually produce all the HTML for an Elm application. So the last thing that we want to look at is what happens after you render a page, right? Because what's going to happen in the first time is that we're going to have some initial value that we specify. It gets passed in as the first value, and then it gets passed into the view, and that's the first thing we render. So for example, when I load in this page, my initial value is 0, so it just loads us in first. But we want to listen for changes, right? So the next thing that happens is we have these things called messages, which are basically like actions in React. And what we're doing, in Redux, and what we're doing here is every time there is a button click on this screen over here, it's going to emit some sort of a message that is going to be captured by the Elm runtime, and then it's going to update the page as a result of that. So the last thing that we need to look at is this actual update function, which is basically the exact same as the reducer in Redux. And what that does is it takes a message, it takes the current state of your application, and what it outputs is what the next state of your application should be, right? So maybe what we have is a model that is like the number 0, and then we have a message of increment. If you pass both of those things into your update, it should output the number 1, right? Because that would be the next model that your page would take on. So basically what happens is you have this initial view, and then afterwards you listen for these messages that are getting emitted, and then every time they get emitted, it's passed into your update, you generate a new model, and then that model is passed into the view, and you render the new page. So that is what we are going to try and implement in React. And then we're going to go back out from there. So let's go. Sweet. So let's write some Elm in TypeScript. It's going to be extremely weird. So the first thing you want to think about is the actual model that we're going to use for a page. So let me actually open this guy up here. And let's delete all of this stuff out. And we're going to start with just a raw index over here.
Enhance, please.
Enhance, yes. Cool. All right. Cool. I'm going to put this guy over to the side because I need to remember all the things that I even wrote to do this. But yes. Cool. So the first thing that we want to do when we're building out this page is we want to think about the model that we're going to use. So what I'm going to do is I'm going to write out a type model. And if I'm trying to create this page that's keeping track of the counter, I really need to keep track of a single number here. So maybe I'd say that type is equal to number. But what I'm going to do instead to make this a little bit more flexible is I'm going to put that inside of an object. So I'm going to say counter, number. And the reason I'm doing that is that there's not really any change in like the functionality of what's going on there. But if I want to add more stuff to track in that state later on, it's really helpful to put that in an object from this way. Next thing I want to do is I want to create an initial state. So that'll also be a type model, and then I'll set that initial state to be a counter that is set to 0. Cool. So now the next thing we need to do is actually build out the view. So in this case, what we're just going to do is we're going to have a const view, and that will take in a model, and this will feel a lot like Redux pretty soon. And what it's going to output is a JSX element, whereas in the Elm runtime, we would be producing HTML. We're just going to be doing JSX here because that is how it works in the React world. So based on this page over here, we have in each one, we had some sort of a counter at the top that would display the state of the page. And then we have a button labeled decrement and a button labeled increment. Cool. So what we're going to do is we're actually going to get the state of this page from the argument passed in. So I'm just going to look at page model dot counter, and I'm just going to render that out as the value for the counter up here. These buttons ideally should be wired up so they actually do stuff when we click on them, but I'm going to say that as the last step because there are a couple things that we need to do in between. So the first thing we need to do is we actually need to set up messages. So what I'm going to do is I'm going to declare a type message, and what I'm going to do is actually pretty similar to what was happening with the web workers presentation. which is that I'm going to make a discriminated union of all the possible messages that could be sent out. In this case, I want to think about the points of interaction on this page, right? So if I looked at this counter, there's really just an increment and a decrement here. So I'm going to say those are the only two actions that a user can take on. So we have our type, which is equal to increment or decrement over there. And then the last thing we need is our actual update. So our update is going to take in it's going to take in a message, and that's going to be a type message, and then it's also going to take in a current model, and then the goal is that it's going to output the new model here. So in this case, when we're writing an update, what I like to do is I like to switch through all the different possible cases in that discriminated union and see where we can go from there, right? So I'll do a switch on message, and what I'm going to look through is the case of increment, for example, and it autofills because I actually declared that type in advance, which is really helpful. And in that case, what I want to return, if it's an increment, is I want to return a new state that looks like the old state, so counter of per model.counter, but I want it to be one bigger because we just incremented, right? So that's what I'm going to do there. And then I also have a case of decrement. And in that case, what I want to do is return the exact opposite. A counter, per model.counter minus 1. Right? So that is our entire update over here. There are a bunch of red squigglies, and I am concerned why they were showing up. But
So .js, not TS.
is that why? Oh, yes. Thank you. That's super clutch. Okay. Sweet.
Probably want to do TSX.
Yes, I'm going to rename it to TSX. This will end well, surely. Oh, it did. Ooh. Hey, it actually did end well. Nice. Sweet. It's angry for other reasons. Is it not returning? Oh, it's because those should be complete parents. Cool. Sweet. So, where do we go from here? So, now what we have is our message, and we have our update, we have our view, and our model. So this is basically the simplest implementation of an Elm application. But what we need to do, since we're trying to do this in TypeScript, is we need to write a little bit of wiring to actually simulate how Elm works. So what I'm going to do is I'm just going to create a class that's just going to contain all of this. And basically, what I want to do is just simulate those updates whenever we receive new messages. So I'm going to write a React component, and then it's going to have a public state, which is equal to init, because the idea is the first time we load in this page, we want to set it to the init value that we specified, and whenever we render this page, we want it to just call that view method that we actually wrote earlier. So a view of this dot state. And we want to pass in our current model. The last thing I'm going to write is a dispatch method, which is just going to simulate the way that we go from the message to the update. So dispatch is equal to, we'll take in a message, or type message, and it's just going to be a void. And what it will actually do is first, it'll create a font, new model, which is a type model, and that will be equal to the update of the message that we just received and our current state over here. So we get the new state, and then the last thing we want to do is we want to say this.setState to the new state that we just got. Okay, we're going to continue from there and get back to that in a second. Sweet. So the one last thing that we need to do is I mentioned that the buttons are actually not wired up here. And that's just because I need to wire them up to that dispatch action. So the last thing I'm going to do is just delete that guy out. And I'm actually going to stick the view inside of here. So I'm going to say public view. And now what I can do is actually call that dispatch action from inside of the button. So I'm going to say on click is equal to, And then I'm just going to do an anonymous callback of that dispatch. And in this first case, I'll pass in a decrement, because it's the decrement button. And then in the second case, I will do a dispatch of the increment button. So with that all said and done, that should be the app in its entirety here. So the last thing is that because we moved that view in, we have to save this stuff. But what we have written up here should be a sort of facsimile of a Elm application here. Still unsure why set state would not actually exist on a React component.
Because you do a dispatch ifs.
Is it because is this syntactic imports screwing me all the way down? Disaster. Yes.
It could be, so I know React components generic. I don't know if you actually have to have a parameter for the specific state
Oh, like within the like two
in the type parameter.
I managed to get this to work on my computer locally. I think it might just be something with the way I configured Parcel that's being finicky right now. I will try and run it regardless, and I think that it will shout at me. But let's actually see. So if I do npm start on this, I really hope that it works. That'd be super slow. But so if I do npm start, okay, cool. So I think that is an issue with the way that I configured.
First, it's still looking for index.js.
Oh, it is.
HTML file.
Flash. Thank you.
Second, maybe switching those imports to import star as React.
Probably is it. If this takes any longer to debug, I'll just ditch it. I'll just show off the Elm comparisons. But yeah, cool. Yeah, I think I'm going to chalk this one up to technical difficulties just because we just very quickly configured Parcel on this new computer. So I think that it's missing a couple of imports. But in any case, totally assume that it worked the exact same way as that really nice thing in So what I was going to do next is I was going to use that code that we wrote to try and explain the differences between the TypeScript syntax and the Elm syntax. So basically, what we have are a couple of comparisons about how we just wrote this in JavaScript and how we would write this in Elm instead. So the first thing is the way that we declared our model, right? So in JavaScript, we say type model is equal to this, whereas in Elm, we're saying type alias. And really, these things are basically equivalent because in TypeScript, when you declare a type, you're really just declaring an alias of a type. And you're saying that this keyword is shorthand for this entire type over here. So in Elm, we're doing the same thing, but we're just sort of doing it more explicitly by saying type alias. The other difference here is that in Elm, you actually have to break out your type declarations into a separate line. And part of the reason behind that is because the type inference system in Elm is really great. So having this in a separate line means that you sort of just opt into it here. But otherwise, those two things are practically the same. The other differences are that in Elm, when we're declaring a view, our method signatures look a little bit different. Instead of declaring the types of each parameter as we're declaring them, what we're doing instead is we're just saying, in general, this is going to take some parameter that's of type model, and it's going to produce some HTML message instead. That HTML message is a little bit interesting. It says we're producing HTML that emits messages, which is the type that we defined earlier. And finally, another weird thing about this is the way that all of the HTML is actually produced. So what we're doing here is we're actually calling methods that are inside of Elm. So div is a method that takes in two parameters. And those two parameters are actually two lists. So what I'm really doing right now is I'm saying div, and then I'm passing in this empty list as the first parameter, and then I'm passing in this list with all the stuff inside of it as the second parameter. And I'm doing that all the way down. The same thing with h1 and button, where I just specify different properties of it. So this is actually closer to JSX than it may look at first pass. Because what really happens is under the hood, JSX gets compiled down into a bunch of like React.createElement things. So in Elm, we're sort of just doing that directly. And there are extensions that will let you do this thing called like ESX, which is pretty similar. But when you're just using raw Elm, you actually have to call through methods. And the one last thing is that in the example I was doing, I had to like hook up this button to this really weird on-click dispatch thing. But in Elm, all I really have to do is if I say on-click and that just returns some sort of a message over here, it automatically gets passed up into our update function, and then that will manage the application from there. So those are some of the most notable differences. But the last thing is actually looking at the message, which is where there's a lot of disparities. So the first thing is that we did a discriminated union between different string types. In Elm, you can just do a discriminated union between like themes, basically. So your message is either going to be an increment or a decrement. And this is actually pretty helpful because the strings that we picked out are really just sort of arbitrary values that don't really matter. What we're really saying is that message should be an A or a B, and we're just giving them two separate names here. So we're sort of skipping the middleman of having these weird strings that we need to store, and we're literally just saying a message can be one of two things. Another thing that's really funky about this comparison is the way that this method header looks. It's a method that takes in two parameters and produces an output. And it might look at first pass like it's a function that like produces a function or something like that. And the reasoning behind this is actually because everything in Elm literally takes in one parameter. So what happens when you declare a function in Elm that takes in multiple parameters like this is what we're really doing is we're actually currying a function. So what we're doing is we're breaking it apart and we're saying we're going to create a function that produces a second function that has the message already filled out, and then we call it, and that method will actually produce a model at the end. So the other reason that these headers look so weird like this type declaration here, is just because the mathematical basis of Elm is based on something called lambda calculus, where you're limited to a bunch of functions that only take in one argument at a time. And this is kind of helpful too because it lets us like partially apply functions, and we can do all sorts of like funky monad stuff, which is a little bit more advanced, but it's really cool. So this one is definitely kind of weird. But other than that, it's actually pretty similar. Sweet. So I am going to, for the sake of time, cut off the second part of this, which is going to be talking about like maybe functions and stuff, and maybe I could break that out later. But that is a brief introduction to Elm and how that syntax looks. The last thing I'm going to do is I'm going to actually just bring up the Ellie page so we can see what the completed code would look like in Elm. And that's all it is. Let me enhance that a little bit here. But you can see what we have are these pieces of our type alias, our init model, our view, our message, our update, and then finally we have this main browser.sandbox over here, which takes care of all that wiring that we're doing by hand. Sweet.
One question on the Lambda syntax. It looks like you're hitting model twice. What's the reason for that, or is it just kind of a weird thing with the syntax?
Yes, so we're not actually hitting model twice. These two are actually both parameters, and we're outputting the model at the end, right? So yeah, so we're currying this guy here. So one way you could imagine it is that if we were to call this function curried, it would look something like message model, like that. And that's how we get in those two parameters. Yes?
So you mentioned that this tends to be faster, at least than React. And so I just want to make sure I'm understanding this correctly. So Elm is a language like TypeScript that gets transpiled into JavaScript, is that correct?
Yes.
And then it also has a library for rendering like React does, is separate from React?
Yes.
Okay, and then that library is the part that is faster than React.
Yeah.
Okay.
It's kind of both at the same time.
Yeah.
Like
it's
Elm
weird.
is TypeScript and React and Redux all very tightly coupled. So so that you almost can't tell the difference anymore. Because like you were talking about with the compiler optimizations.
Yeah, I mean, like, it literally is like its own standalone language, right? It's just under the hood it eventually becomes JavaScript. But you're right, the library packages for all the HTML rendering is the reason that it ends up being so fast.
Does it, if you compile the Elm file then, so I'll back it up. If you compile a TypeScript file, it basically looks like the JavaScript.
Yeah.
If you compile Elm, I'm assuming that's not the case then.
Yeah, I actually haven't looked at what a compiled Elm file looks like, really. I've just messed around in Ellie and then on my own computer, I've just checked it out, but I haven't poked into it. I would be interested to see. I think it'd probably be not readable, but I'm not sure. Yes, it does. So that's why it's really fast. It does a virtual DOM, and then because that view method is totally deterministic, it can make like more optimizations based on that.
Yeah, it's. I don't want to interrupt the question.
Is there something similar like promises?
Promises? Yeah, there's actually, Elm has like a bunch of really cool ways of dealing with async stuff, but I can't really talk exactly on that right now. I haven't messed with all the promises stuff, but do people who have used Elm know more about this?
Isn't it just like you fire it off and then it's going to return a message to your digest when it's done?
I would imagine it would go through the update, right? At the very end.
Right.
Yeah.
Right. I want to say that the response from any async thing has to come in through update.
Yeah.
Okay, so you cut it into basically. You cut it into like you say you want to do something, and then something is like pulled apart, and then at the end it's another.
You later find out about it. I don't know much about it. I'm really far on a limb here, but I think
Yeah.
that's what I remember.
Hey, I have a question.
Yeah, sure.
Like you were talking about the React and Elm. As per I know, React is the one which render the view, not the Elm, right?
Yeah, so basically what I was trying to do is simulate the way that Elm would also like update its view every time that it receives something. So what I was doing when I was doing like set state, for example, in React, is I was simulating the way that the Elm framework actually, when given a message, will just re-render the entire page. But the analogy isn't perfect.
So the both React and Elm both are doing the render?
They're
Same
both
time?
totally separate. So what I was writing in the first case was a TypeScript React file that does an equivalent thing to what this Elm file I wrote right here does. So they're two totally separate ways of doing this.
So Elm does not do anything with view, you mean to say?
So Elm does do stuff with view. We have an init, a view, and an update, and a main, but it's not interacting with like React at all. This is all a standalone file that would do its own thing.
So you mean view means whatever is visible to the user, right?
Yes.
So Elm does participate into that?
Yes, it does. It does do that. Yes. So the Elm architecture is just you take a view and it receives a model and it will output that view to your browser. So that's how it manages it.
Elm replaces React and TypeScript.
Yes, it totally replaces it. So just like how React has a virtual DOM, Elm also has like its own virtual DOM. It's just all a totally separate way of doing it.
Isn't it like in the React, the render method, whatever will be inside the render method, that is only the view, right?
Yeah, basically. And the view is almost like a render for the entire page. It's not like there's a concept of like components underneath it.
So in the render method, anyways, we're not writing anything with the Elm. It's HTML, completely HTML.
Yes.
It's not Elm.
Yes.
Or it's like that.
It's this stuff over here, which is HTML, but it's calling this library of HTML functions under JavaScript that produces the stuff that's rendered on the page. So these functions here are most analogous to React.createElement, which does effectively the same thing. We're not just producing raw HTML because we need to do stuff in the virtual DOM to optimize it.
Thank you.
So really quickly, are there any, I'm guessing you wrote this in code as well before you copy and paste it to Ellie? Or
Yes, I did. So yeah, so I read this before. I read this on my laptop, so there's a little bit that was lost in translation. But I did write this in VS Code.
No worries. I just want to ask, are there any extensions that help you write that type of syntax?
Yes.
Okay.
So I think Ellie was my tip for like if you're just trying to test this out one time because it's just zero config. If you go to the VS Code extensions place there, if you search for Elm, it is the first extension and it has all the syntax highlighting in it. And then if you do an npm install Elm format, then you can also get sort of like a prettier type thing where it also like formats it down into the standard Elm file thing. So yeah, so you can totally get this working in VS Code. I have it set up on my laptop right now, and it's great.
All right.
Thank you.